Chapter 1.4.2.4 DaemonSet. A DaemonSet ensures that all nodes in a cluster run a copy of a pod, adding pods as nodes are added and removing them when nodes are removed. Deleting a DaemonSet removes the pods created. Typical uses include running storage, logs collection, and node monitoring daemons on every node. Simple setups use one DaemonSet for each type of daemon, while more complex setups may use multiple DaemonSets with different configurations for different hardware types. Writing a DaemonSet spec. A DaemonSet in Kubernetes is described in a YAML file, such as the DaemonSet.yaml file that can run the FluentD Elasticsearch Docker image. When creating a DaemonSet, certain required fields such as API version, kind, and metadata must be included. The name of the DaemonSet object must be a valid DNS subdomain name. The .spec section is also necessary, which includes the pod template. The pod template in a DaemonSet is nested and does not have an API version or kind. It must have the restart policy set to always or be unspecified. The pod selector specifies the labels of the spec.template and cannot be mutated once the DaemonSet is created to avoid orphaning pods. The selector can consist of match labels and match expressions for more advanced selectors. The DaemonSet controller can create pods on specific nodes based on node selector or node affinity specified in the template. If neither is specified, pods will be created on all nodes. It is important to ensure that the spec.selector matches the .spec.template.metadata labels to avoid rejection by the API. How daemon pods are scheduled. A DaemonSet in Kubernetes ensures that all eligible nodes run a copy of a pod. The DaemonSet controller creates a pod for each eligible node and matches it to the target host using the spec.affinity.nodeaffinity field. The default scheduler then binds the pod to the target host by setting the .spec.nodename field. If the new pod cannot fit on the node, existing pods may be preempted based on priority. To prioritize the DaemonSet pod running on each node, setting the .spec.template.spec.priority class name to a priority class with a higher priority is recommended. Different schedulers can be specified for the pods of the DaemonSet by setting the .spec.template.spec.scheduler name field. Taints and tolerations are automatically added to DaemonSet pods to allow them to run on unschedulable nodes. It is important to ensure that DaemonSet pods are placed on nodes before they are ready, especially for critical functions like cluster networking, to avoid deadlock situations. Additional tolerations can be added to DaemonSet pods as needed, enhancing flexibility and customization. Communicating with daemon pods. Possible patterns for communicating with pods in a DaemonSet include push, where pods send updates to a stats database without clients, node IP and known port, where host port is used for pods to be reachable via node IPs, DNS, where a headless service is created for discovering DaemonSets, and service, where a service with the same pod selector allows reaching a daemon on a random node without being able to reach a specific node. Updating a DaemonSet. When node labels are changed, the DaemonSet will add pods to matching nodes and remove pods from non-matching nodes. You can modify the pods created by a DaemonSet, but not all fields can be updated. The DaemonSet controller will use the original template when a node with the same name is created. Deleting a DaemonSet with cascade = orphan will leave pods on the nodes. A new DaemonSet with the same selector will adopt existing pods, replacing any that need to be replaced according to its update strategy. A rolling update can be performed on a DaemonSet. Alternatives to DaemonSet. The text discusses the different options for running daemon processes in a Kubernetes cluster, including using init scripts, daemon sets, bare pods, static pods, and deployments. Init scripts allow for direct starting of daemon processes on a node, but using daemon sets has several advantages, such as the ability to monitor and manage logs, using the same config language and tools as applications, and increasing isolation between daemons and app containers. Bare pods can be created directly on a specific node, but daemon sets replace pods that are deleted or terminated due to node failure or maintenance. Static pods can be created by writing a file to a directory watched by kubelet and do not depend on the API server, making them useful for cluster bootstrapping. Deployments and daemon sets are similar in that they both create pods, but deployments are better for stateless services, while daemon sets are ideal for ensuring that a copy of a pod always runs on all or certain hosts to provide node-level functionality for other pods, such as network plugins.